after title, we will write the abstract. The abstract should be a concise paragraph describing the whole experiment together with the results and the major conclusions. Even though this is a second section, but I would usually write it last. The reason is that when I write this part, I want to have all the experiments information, results information, and the conclusions ready. So I would write everything else and come back to this section and write the abstract. Because this has all the information and this part needs to be concise so that when other scientists are reading your report, sometimes they can just read your abstract without going into all the details of your experiment. They can get the conclusion, they can probably get enough information so that they don't need to read the whole report. So that's the idea. They don't need to read the whole report unless they really want to look into the details of your experiment. So you need to have a concise, all information in this part. So this is very difficult to write. And in this part, make sure you use correct scientific language, use the right keywords. The abstract should be usually less than, I would say more 200 words. The less will be better. So you don't want to put too much wording in this section. No reference to literature here. So if you say our conclusion is this, and it's very close to the reported literature value, when you say that, if that's in the body of your report, you would put a reference number there so people can look for the reference. And in the abstract part, you don't put down the reference number. So if the readers are interested, they can look into your report and probably find the literature. So no reference to figures in the body of a main paper. You don't want to guide your readers to a certain part of your article. For example, you don't want to say our conclusion is shown in figure number 3 of this article. You don't want to say that because you want to contain all the important information just in the abstract itself. So people don't need to read through your paper. No reference to figures in the body of a main paper. Focus on what's studied, how, and what was observed and concluded. I've seen some papers, even the published papers in good journals, people like to put down some part of their introduction into the abstract that make it long and not necessary. So the introduction part we'll see is about why our study is important and what have been done by other people in the past. So that information is interesting and important. However, you don't want to put that information in the abstract because we don't want to put too much in here. We want to limit how much words we'll use here. So make sure as when you write this part, write it as concise as possible. I want you guys to take a moment. So you have down the ethanol data. I want you guys to take a moment and think about the abstract that you might write for the vaporization lab. If you have your notebook, you can write down a couple key points, what you want to put down in your abstract. We'll see an example of it, see if that matches with what you want to say in your abstract. Okay, did you guys write down some key point that you want to include in your abstract? In your key point there, we can find what's studied. So ethanol and cyclohexane and how. So use vapor pressure as function of the temperature and what. So enthalpy, and the boiling point. So let's take a look at the example I put here. The first sentence is the same. I give more detail about the measurement we got. So I would give I want to mention here is the analysis was done by the Clausius-Clapeyron equation. So I put down the equation here. Also put down the numeric value of each parameter we measured together with uncertainty. Write down the normal boiling point also with the numeric value together with uncertainty. So that'll be all. And this, you can see we put down one sentence, two sentences, and three sentences. That will cover all the information we have down for this lab. I also include a journal article there. They were also doing the pressure temperature measurement, and you can use this article as a reference to see how they put down their experiment. You can write your lab report basically the same way. So you can find this journal article with the journal name and the title, and you should be able to find it through SciFinder. Number 4 is the introduction. So as I mentioned before, basically it's to write down the summary, the purpose of the paper, and the relationship to the broader field of chemistry. The broader field of chemistry, basically that is what people have done that's kind of related to our experiment in the past. So that introduce the topic, put the paper in perspective for the readers, and usually that's done by a literature review. So the reason the reader probably is reading your article is because they have seen some other research and feel interested. So they are reading your article. If you have some literature review about what have been done in the past, and reader will feel more interested. And you will state the overall larger goal of your experiment. And then can narrow it down to the exact goal for your experiment. So the exact goal for our experiment here is to measure the entropy enthalpy for the vaporization of two chemical compounds. After that, we'll measure the normal boiling point. So you want to state the exact goal in this section. And then in the end, when people read to the conclusion and results of discussion, they'll find your goal is reached after the experiment. So make sure starting with something relevant and big, and eventually narrow down to exactly you want to talk about in your lab report. And try to avoid some lab reporty sentences like this one. The purpose of this experiment was to do what? Usually, if you want to state your goal, I would say the goal of this study, I would not say this experiment, because in many reports that contains a multiple experiment. So I would say the purpose of this study was to measure the entropy enthalpy of vaporization, things like that. I want you guys to think about how would you introduce a vapor pressure experiment. I'll give you guys a couple minutes. You can think about it, and I'll show you an example of it. Okay, so this is an example of the introduction. I would start with the broader background of the phase equilibria in I would say the study of phase equilibria in compounds play an important role in many real-world applications. For example, understanding the relationship between vapor pressure and temperature relationship is useful, and you can list some examples. Probably look up some literature and find examples. So here, well, for example, we use the case of pressure cooker. That application for pressure cooker depending on the temperature and the vapor pressure, right? And you can list other applications such as, let's say, the electricity generator that's pushed by the water steam in many cases. So the pressure of that water steam has a dependency on temperature. So those kind of application will make your reader feel interested. After that, I would relate that directly into my study. So in the studies presented here, the enthalpy and the entropy of vaporization for this compound were determined using a classic Clapeyron treatment for boiling point versus applied pressure. Sort of stated my goal here. Then I also guide my readers that what's they going to find after they finish reading the article. So I was saying the differences observed in the results is discussed with respect to structural features of the compounds examined. Because later on in the discussion session, I would look at the difference of boiling point between ethanol and cyclohexane, and I want to look into how the chemical structure is affecting the boiling point. So I will tell some information about that here. That's kind of similar to show I have a goal in my experiment here, and you can find the answers to those goals later on in the article. And the key point is studying something broader than maybe describe as what other people have done related to your topic, and then close on what you are going to do, what you are going to discuss in this paper. Well, also, you need to be concise in every article you write. So basically, I would imagine for this experiment, you need 4 or 5 sentences in the introduction part. After that is theory. So basically, this part is to reiterate what your understanding is about this experiment. You need to develop the equations, how you calculate your answers here. All equations and the relationships must be developed, defined in this section. Later on, when you show readers your results, your discussions, you don't need to repeat your discussion about these equations again. Define the chemical physical process involved. Well, by the way, there's many real-world paper does not have a theory section. For many of them is that they themselves is trying to develop a new theory. So they use their experimental session and discussion session to develop the theory, which is fairly new and it's not done by others. So they don't have a theory section. And in this section, you need to define all variables presented in equations. So if you want to use a P to represent your pressure, you want to define, okay, for this paper, P means pressure. You want to define G, for example, you want to say G, it means gas. So you want to define G equal to gas in this section. Make sure you develop equations, do not derive them. What does that mean? You do not need to show step by step how you get to each equations. You can jump to a few steps. So for example, if you're using Clapeyron-Clausius equation, you can just say, I will use that Clapeyron-Clausius equation. And also based on the delta G equal to 0, we can get the boiling point T equal to minus delta H divided by delta S. There's no need to write every step. And the equation must be numbered to facilitate the references throughout the remaining of the paper. So when you, in your results section, when you want to show that linear relationship, you don't have to restate the Clapeyron-Clausius equation again. You would just be able to say, okay, based on equation 5 that you show in the theory part, then we develop a linear relationship shown in the next figure.